I'm Jason Tatge, CEO and co-founder of Farmobile. We oftentimes get the question of how is the PUC able to collect real-time data from a mixed fleet of machines and display it on one screen. So I figured we'd take 5 and talk about it. So a lot of people think of us as a PUC company, and I will say the PUC is a very, very important piece of what we do, but it is the tip of the iceberg. Most people who think that they can build one of these and make this work and it's easily replicable don't understand what they don't know yet, just like we didn't when we started. And we work at startup speed for the last 4 years to identify the best practices to getting data into a database. But the real work starts when you have to organize that data, and it's every bit as hard to organize that data. And then there's another piece, it's getting that data out. So we like to say that we're the only system designed to bring data in, normalize it, get it out as quick as possible. And that's really what the PUC is all about. So over the lifetime of this thing, this is our 4th version of it, by the way. Over the lifetime of this product, Chris, what are some of the engineering challenges that we've had to address head-on that most others in the industry hadn't tackled yet?
So let's start with the PUC. I mean, we're collecting data. It plugs into the diagnostic port of the farm device implement. This data comes out. The first challenge is we have to be able to predictably translate that data into something that can be understood. Okay, we're talking about very technical hexadecimal messages. Turning that into something that can be transported back into a system that provides a human readable capability. There's a lot of things to consider along the way. The first of which is just data communications. When we talk about data communications, we're talking about cellular connectivity. What a lot of people don't understand is that in rural areas, cellular connectivity is inconsistent. It's non-deterministic. So one of the problems that we've had to solve is how to ensure the consistency and integrity of that data as it's being collected and then transmitting that to the back end. So data communications is one piece of that. The second piece of that is doing that with a latency that can still be considered real time. One of the things that we take pride in is that when the PUC is collecting data, and you're seeing that PUC on the back end through our data engine platform, and I'll talk a little bit more about that in a minute, is we're looking at roughly 2 to 3 second latency time. And so if you think of all the hops that piece of data has to take, it has to get from the device into the cloud through our cellular communication data provider, then it has to be transmitted to our back end cloud provider, which in this case is Amazon Web Services. And then we have to take that data, do the translation part of that, and then put that through our presentation tier to provide meaningful information. And doing that in a 2 to 3 second latency, let's just say, is not for the faint of heart. Everybody claims they can do it, but when you really see what we've done and some of the engineering challenges that we've had to overcome to do that in a predictable way is very challenging.
Today, agronomy is reactive today. Okay, we look at, if we have data, we look at data from a thumb drive or from a terminal that was done several days ago, not seconds, and then we try to augment that maybe with some aerial imagery layers that maybe a couple days or weeks or months old. So we're always looking backwards. What this device allows us to do is allows us to look forward. So we get to be proactive in those fields. You get to, with trusted advisor agreements, you get to see what's happening on that field and that farmer within 3 seconds. Okay, so your ability to prevent mistakes that are being made goes way up, and that's a huge service. And your ability to then make different decisions throughout the season based upon what just happened and you're seeing the reactions to it changes the game of agriculture. It changes the game of global agriculture because we've never been able to have access to real-time data like this. And this is like we don't know where this will lead, but here's what we do know. We do know that the game will look very different in the future because people will have access to real-time data.